Testex replica tape can be used with a micrometric thickness gauge to determine the roughness of a grit-blasted steel surface prior to painting. The tools you will need to do such a measurement are a thickness gauge, at least one roll of replica tape, but preferably two, one coarse grade and one X-coarse grade, and a burnishing tool. Be sure the gauge is one that has been specifically designed for use with replica tape. A gauge measuring in thousandths of an inch, or mils, looks like this. A metric gauge measuring in micrometers, or microns, looks like this. Select the grade of tape that is closest to your target profile. If your target profile was, say, 3.5 mils, or equivalently 90 micrometers, you would select X-coarse grade. If your target was 1.5 mils, about 38 micrometers, you would select coarse grade. Here our target profile is between the two. We'll try the X-coarse grade tape first. Before doing anything else, we need to set up the gauge. This is as simple as first making sure the anvil and contact surface are clean, and then presetting the gauge to subtract the thickness of the incompressible layer. On an inch gauge, this means presetting to -2 mils or +8 mils. On a metric gauge, it means presetting to -50 micrometers or +150 micrometers. To make sure everything is working properly, pre-gauge a piece of tape. If you're using X-coarse grade, you should see a thickness between 5 and 6 mils. If using a metric gauge, the thickness should be between 125 and 155 micrometers. Apply the tape to the blasted surface. Press the adhesive-backed paper to hold it securely in place. Firmly compress the replica tape with the smoothest surface on the rounded end rubbing tool provided, applying sufficient pressure to produce a replica with a uniform pebble grain appearance. Use either a circular or XY rubbing motion. Fully compress all parts of the film, but be careful not to slide the film with respect to the blasted surface by bumping the edges of the circular paper cutout. In general, too much compression is better than too little. In a pinch, the rounded edge of the tape dispenser is also an acceptable tool. Now, remove the replica and place it centered between the gauge anvil and the contact surface. The gauge reading is a measure of the peak to valley roughness, or profile. Here is where it is helpful to refer to the figure on each piece of tape. If the measurement you just took is within replica tape's measurement range of 0.8 to 4.5 mils, or 20 to 115 micrometers, but outside the overlap region between coarse and X-coarse grades, you are done. Take the reading you just obtained and record it. If, as is the case here, the measurement is within the overlap range, Testex recommends that you take a second reading, this time with the other grade. If both measurements turn out to be within the 1.5 to 2.5 mil window, we will average them. If the second measurement is outside that window, we'll use it as is without averaging. We used X-coarse grade tape for our first measurement, so we will use coarse grade for the second. In this case, our first measurement was 2.2 mils, and our second was 1.6 mils. Both are within the overlap window. So we'll add 2.2 to 1.6 and average by dividing by 2. Adding these numbers gives 3.8, and dividing by 2 gives 1.9. That's our profile. We are done. If the second measurement had been outside the overlap window, say 1.4 mils or 36 micrometers, we would have written it down as the profile. In short, if both measurements are within the overlap window, average them. If either is outside the window, use that as your measurement. Remember, all the numbers you need in order to use the averaging procedure are on the tape itself. These instructions can be used with replica film on Testex old-style tapes. Though the newer averaging instructions are recommended and give better, more consistent profile values, inspectors do have the option of using the older, non-averaging instructions where required for consistency with earlier measurements. Additional details can be found at www.testextape.com.